Assalamualaikum and good morning everyone. Okay, so today we will continue the lesson for complex number. Don't forget to watch the video in the previous lesson yang Madam dah bagi sebelum ni. Boleh tengok dekat description. Okay, so hari ni Madam akan sambung to the next subtopic in complex number, which is about the conjugate of a complex number. Okay, so what is the conjugate of a complex number and how to use the conjugate of complex number, okay, in our calculation. So let us start. Okay, conjugate of a complex number. Okay, say we have a complex number Z equals to A plus BI. Then the conjugate will be Z bar equals to A minus BI. Okay, for example, let me show you. Okay, so over here, say I have, okay, Z equals to 3 plus 4i. Okay, then the conjugate will be Z bar equals to 3 minus 4i. Notice that we only change the sign. Okay, what sign? We change the sign of the coefficient of I. Okay, let me show you another example. Okay, so over here, say I have Z equals to 2I minus 3. So what is the conjugate? So I will write Z bar equals to, okay, we need to change the coefficient, the sign of I. Okay, so here is positive 2, then it become negative 2. I, it's still minus 3 over here because remember we only change the sign of I. Okay, so why we need to learn about the conjugate of a complex number? It's because we want to solve question like question number 6 over here. Okay, so let me show you question number 6. Rationalize the denominator. So when we want to rationalize the denominator of the following fraction that involve complex number. So rationalize means our final answer, okay, final answer don't have any I. Don't have any I. Say here is a number over I. It cannot be denominator has I. Okay, so you must make sure your final answer doesn't have any I in the denominator. So all of these are not the final answer because we can see that there's I in the denominator. Okay, so during the calculation, you might have this situation where you have I in the denominator. So you need to simplify and rationalize it so that you can get a complete answer. Say for example, I have final answer 2 over 4. We cannot leave this as our final answer because we can simplify it again to be 1 over 2. Okay, so in complex number, we also need to simplify our answer and make it rationalized so that we don't have I in the denominator. Okay, so I hope you understand the term rationalize used in this chapter. Okay, so let us try one or two of the questions. Okay, and then you will try on your own to answer the remaining of the questions. Okay, let us try question A. Okay, so for part A, we have 2 over 1 minus I. Okay, 2 over 1 minus I. So we don't want the I over here. We need to multiply, okay, numerator and denominator by the conjugate. So the conjugate of the complex number over here will be 1 plus I, right? Okay, we change the sign of the I. Okay, over here is also 1 plus I. Okay, next we will continue with the calculation. Okay, for the numerator, okay, the numerator over here, okay, so we need to multiply 2 times 1, 2, and then 2 times I becomes plus 2I. Okay, and for the denominator, over here, the denominator, we will use this formula. Okay, take the first number. You can see that the first number are the same, right? Both have 1 in the first number. So I put 1 squared. Okay, and now I have the second number I. So I put I squared. And the relationship in the middle will always be minus. Okay, so we will try to solve. The numerator is just the same, 2 plus 2I. But the denominator, 1 squared is 1 minus I squared is negative 1. Remember, we have the rule over here. I is equal to cert negative 1 and I squared is equals to negative 1. So this is what we have over here. Okay, and then we just need to simplify and we can see that we have 2 plus 2I over 2, right? So here become plus, right? Negative, negative become plus. So 1 plus 1 is 2. And then we can see that here the denominator has no longer I. Kita tak ada dah I dekat bawah ni. Jadi, kalau kita tengok ini, kita boleh simplify lagi. We can simplify it again because we can factorize 2. Okay. And then we have 1 plus I over 2 and we can simplify this. So the final answer will just be 1 plus I. Okay. I hope you understand this. Now let us try question B. Okay, question B. So we have 4I over 4 plus 3I. Okay, so let us try question B. Let me write again the question. So for part B, okay. Sorry, okay. B, we have 4I over 4 plus 3I. Okay, what is the answer? What is the rationalized answer? Okay, so first of all, we note that there's I in the denominator. So we need to do something. Okay, so we need to multiply with the conjugate. Okay, so let us multiply with the conjugate. So in this case, the conjugate will be 4, what? 4 minus 3I. Okay, so here is 4 minus 3I. Mesti sama lah atas bawah. Okay, and then we will expand the numerator. First, we have 4I times 4. So we'll get 16I. Next, we have 4I times 3I. Okay, so here we have negative sign. So we put negative. And then 4I times 3I. Okay, so we multiply the number first. 4 times 3 is 12. Okay, and then I have I times I, which is I squared. Okay, divided by the multiplication of the conjugates over here. Okay, we can see that the first numbers are equal, are both 4. So we write down 4 squared. Okay, and then we have 3I for the second number. So we put 3I squared. Semua mesti squared lah, jangan I sahaja. 3 pun mesti dikuasa 2 kan. Okay, and the operation in the middle will always be negative. Okay, so let us try to simplify this. The numerator will become 16i minus 12. And then here we have I squared, which means negative 1. Okay, over. Then we have 16 minus. Okay, remember the first number is 3. So 3 squared is 9. Then we have I squared, which is I squared, like this. Okay. Next, we will continue. Okay. So we have 16i plus 12, right? Okay. Negative, negative become positive. And then over 16 minus 9. And here we have I squared, which means we need to write it as equal to negative 1. Okay. So we can solve this to be 16i plus 12 over 16 plus 9. Okay, so the final answer will be like this. Okay, so 16 plus 9 is 25. Okay, so in complex number, if you can recall, the Cartesian form is Z equals to A plus BI. We can see that the real and imaginary parts are separated. So in this case, you must rewrite your answer as follows. 16 over 25i plus 12 over 25. Okay, so you must separate the real and imaginary part. Kita tak kisah nak letak real dulu ke kat depan, nak letak imaginary dulu kat depan, tak kisah. Yang penting you all separatekan the real and imaginary part. Okay, so itu untuk conjugate of a complex number. Next, kalau kita tengok kepada number 7. Okay, number 7 we want to solve. Okay, so we want to solve the equation for x and y. Okay, so let us try solving this. Okay, say I want to solve question A. Okay, so in part A, we have x plus yi equals to 2. So how to solve this equation? We will use the concept of equality of two complex number. Okay, so let us proceed. Here we have x plus yi equals to 2. Okay, so I can write actually over here plus 0i. Okay, so we can compare. Okay, so we can compare real part with real part on both sides. So for real part, I have x equal to 2. Okay, and then the second one is the imaginary part. I will compare with the imaginary part for both sides. So I have imaginary part to be y equal to 0. So this is the solution for question A. Okay, so we just compare the real part and imaginary part and get the values of x and y. Okay, so now let us try question B together. Okay, so B, we have this question. Let me copy down the question first. For part B, I have x plus yi equals to 3 plus I and then 2 minus 3i. Okay. So in this case, we cannot directly compare because over here on the right hand side, we need to simplify it first. Okay. So we can see that here we have two brackets, meaning that we need to expand the brackets. Okay. So let us try expanding this bracket. Over here, I have 3 times 2. So I'll get 6. And then we have 3 times negative 3i. So we have negative 9i squared. No, there's no squared, right? Only I. Sorry. Okay. 3 times 3 is 9. And then we just put the I. Okay. Next, let us continue. I times 2 is 2i. And finally, we have minus, okay, minus 3i squared. Okay. Next, let us continue. So we have over here 6. These two we can add. Okay, negative 9 plus 2 become negative 7. Okay, and over here, notice that we have negative 1. So we put negative 1 to substitute the I squared. Okay, next, we will try to simplify. So we'll get 6. Here become plus 3, right? Okay, negative, negative jadi tambah. So 6 plus 3 is 10 minus 7i. Okay, so now the left hand side, we already simplify it to be 10 minus 7i. Okay, so let me copy again. The left hand side over here, it is x plus yi. Okay, at this point, now you can compare the real and imaginary part. So write down real. Okay, so for real part, you will compare x with 10. Okay, so directly you get the answer x equals to 10. Okay, and then for the imaginary part, we have y and negative 7. So imaginary part, we have y equals to negative 7. Hence, this is the answer, the solution for x and y. Okay, so I want you to try, okay, question C and D, if you can see. Okay, I hope you can see it clearly over here. Okay. So, yeah, question C and D, you can see it clearly over here. Okay, over here, we have x minus 5i equals to y minus 2i over 3i. Okay, so please use the knowledge about rationalize the complex number to solve C and D. Okay, please try C and D on your own. Okay, next, let us look at question number. What number is this? Yeah, question number 8. Okay, so this is a popular question. Okay, pernah ditanya dalam peperiksaan sebenar ya. Okay, so given this complex number over here, okay, find P and Q if P and Q are real numbers. Okay, if P and Q are real numbers. So there are two situations over here. Okay, let us look at the first situation. Okay, P and Q are real numbers. Okay, so let us write down 1 plus 2i multiply with P minus 2. Q equals to negative 1 plus I. Let us treat P and Q as real numbers. Okay. So if P and Q are real numbers, okay, first of all, we need to expand this. Okay. So if I expand, 1 times P is just P. And then 2I times P is 2PI. Okay, and then minus 2q equals to negative 1 plus I. Okay, so now we can compare. So if we compare, we will get real part and imaginary parts. Okay, let me show you the real part. Okay, so here is the real part. P and negative 2Q. Macam mana nak tahu real part? Dekat nombor tu tak ada I. Itu je. Senang je nak identify real part. Okay, so dalam kes ni kita ada P dan juga negative 2Q. Dan on the other side, we only have negative 1. So, write accordingly. Okay, maksudnya kalau yang sebelah kiri tu kita ada P tolak 2Q. Tulis semualah sebelah kiri. Okay, and then equal to negative 1. So, this is real part. And let me write down the imaginary part. Okay. So the imaginary part will be 2p, right? So I write down 2p equals to, over here, apa coefficient dia? Mestilah 1 lah kan? Okay. So now we have two equations. Okay. P minus 2q and 2p equals to 1. Okay, so how to solve this? Okay, we will solve this equation simultaneously. So let me start with here. I can get P equals to 1 over 2. Okay, P equals to 1 over 2. And then substitute in here. So I have 1 over 2 minus 2q. Okay, then we can have 1 over 2 plus 1 equals to 2q. Okay, 3 over 2 equals to 2q, hence q is equal to 3 over 4 kan. Sebab 2 ni bawa turun bawah jadi per 4. So we have the answer for q 3 over 4 and p 1 over 2. Okay, so this is the solution where we treat p and q as real numbers. Okay, maksudnya kita just expand saja seperti biasa. But what if we treat P and Q as complex numbers? Okay, what if the P and Q are complex numbers? Okay, so let me rewrite the question again. Okay, let me write it over here before I zoom in. The same question, okay, I will use the same question for part B. 1 plus 2i times P minus 2q equals to negative 1 plus I. Okay, but now we are treating P and Q as complex numbers. Okay. Wait, let me double check. Okay, let me double check. Takut salah ajar. Okay, jap. Okay, if P and Q. Okay. So over here, if you read the question, okay, you can see that P and Q are complex number and Q is the conjugate of P. Okay, Q is the conjugate of P. So if P and Q are complex numbers, then the first step is you need to let P to be any complex number in the form of unknown. Okay, katakan kita let sebagai A plus BI. Okay, and given that Q is the conjugate of P, so Q is the conjugate, meaning that it become A minus BI. Again, Madam ulang kenapa dalam soalan B ni kita kena let P sebagai A plus BI is because in the question state that P is a complex number. Bila complex number kita faham dia mesti ada dalam dua alam lah, imaginary and real parts. Okay. So that's why I need to let. Kalau macam soalan tadi, P ni real number sahaja. So hanya satu part and imaginary part. Dan jawapan akhir nanti pun awak mesti tulis P sama dengan apa? Contohnya 3 tambah 2I. Jawapan akhir pun mesti dalam bentuk complex numbers. Okay. So kalau soalan A tadi jawapan akhir, awak boleh tengok jawapan akhir dia dalam bentuk real number je kan. 3/4. Tak ada I pun. Okay. Tapi untuk soalan B sebab P and Q are complex number. So kita mesti let as A plus BI and Q ni A minus BI because it is stated in the question. Q is the conjugate of P. Okay. Sekarang mari kita cuba zoom sikit dekat sini supaya awak boleh nampak dengan jelas. Okay. So now we will continue. Okay. The solution by substituting P and Q with the following A plus BI and A minus BI. So let me write down 1 plus 2I times P. Okay. And then minus 2Q. Q is A minus BI. Okay, equals to negative 1 plus I. Okay, so here nampak Madam gantikan P dan juga Q. Sebab sekarang soalan ni kata P dan Q itu adalah complex numbers. Okay, so now kita akan expand seperti biasa. Okay, so we have 1 times A, which is A. And then 1 times BI, we get plus BI. Next, we have this one. And here. Okay, 2 times B is 2B. Then we have I times I, which is I squared. Okay, and then for the second one, we have 2A. And then negative, negative become positive. Okay, equal to negative 1 plus I. Macam tu. Okay, so now kita akan cuba simplify dan gantikan I squared ini dengan negative 1. Okay. So here I have A and minus 2A. So it become negative A, right? For the second one, I have BI and then plus 2BI. So becomes 3BI, right? Next, we have 2AI. Dia tak ada kawan. So, hanya ni je lah. 2AI. Dan di sini kita ada I squared. So, kita akan gantikan 2B times I squared. Maaf. Negative 1. Okay. So, kita akan ganti dengan negative 1. Macam tu. Okay. So, this is equal to negative 1 plus I. Tolong jangan bawa yang sebelah kiri ni ke sebelah kanan ni ke kiri. Biarkan saja yang di bahagian kiri ini. Okay. Ni biarkan jadi di tempat dia. Okay. So next, kita akan tengok apa yang kita boleh simplifikan. So ini akan jadi negative 2B. Okay. So negative A plus 3BI plus 2AI minus 2B equals to this. Okay. So now we can compare. Sebab semuanya dah cantik. Compare. Okay, what is the real part? So in this case, the real part is negative A minus 2B equals to negative 1. So negative A minus 2B equals to negative 1. Then we have imaginary part. Okay, for imaginary part, we have 3b plus 2a equals to 1. Okay, so 3b plus 2a equals to 1. Ingat, untuk imaginary part, jangan ambil I. Sebab kita hanya ambil part dia sahaja. Okay, imaginary part. So, jangan ambil lah huruf I tu. Okay, so here we have two equations. So, meaning that we need to solve it simultaneously. Okay, untuk solve simultaneously, ada beberapa cara. Mungkin kita boleh guna elimination method lah kali ni. Okay, tadi dah pakai substitution. Okay, so katakan from equation 1 tadi. Okay, madam ada A. Sini ada A, sini ada 2A. So mungkin dia boleh darab equation ni dengan 2. Okay, so madam akan dapat negative 2A minus 4B equals to negative 2. Ingat, madam darab 2 dekat semua nombor ni. Kenapa madam darab 2? Sebab madam nampak kat sini ada 2A. Supaya bila sama 2A nanti boleh tolak atau tambah. Okay. So di sini mungkin madam boleh tulis. Okay. Sekejap. Nak bagi jelas. Sini madam gariskan dulu. Okay. Untuk step ni adalah madam darab equation 1 darab 2 multiply by 2. Okay. So now this become equation number 3 lah sebab kita dah ubah kan. Okay. After that, tengok dekat sini. So madam akan susun A dekat depan. Dia tak berubah tapi madam susun A kat depan. So I have 2A plus 3B equals to 1. So this is still equation number 2. Sebab tak ubah pun. Ubah kedudukan je. Kita tak ubah nombor. Okay. So madam buat garis ni untuk bagi jelas untuk awak nampak dengan jelas. So now, kalau kita nak hilangkan A ni, okay, kita kena tambah lah. Supaya negatif 2, kalau you tekan calculator, negatif 2 tambah 2 akan jadi kosong. So sini habis. Okay, and then kita tengok yang ni pula. Negatif 4 plus 3. Negatif 4 plus 3 kita akan dapat minus B. Okay. So here is minus B. Equals to, now, negative 2 plus 1 is negative 1. Hence, we know B is equal to 1. Cepat kan? Daripada nak guna substitution. Tapi tak kisah, nak guna substitution method pun tak salah. Penting kita pilih jalan yang cepat lah. Okay, so now we have B equals to 1. So you can substitute this value B equals to 1 in any of the equation 1 or 2. Okay, so kalau nak tengok senangnya mana-mana pun boleh. Okay, tak ada salah. Okay, so katakan madam nak ganti dalam equation number 1. Okay, so I write down sub B equals to 1 in equation 1. Okay, so I have negative A minus 2 kan. Negative A minus 2B. The B is equals to 1. Okay, equals to negative 1. Macam tu. Okay, and then we just simplify. So I have negative A equals to negative 1 plus 2. We get over here is 1. Hence, A is equal to negative 1. Okay, so let me rewrite the answer that we get. A is negative 1 and B is 1. This is not your final answer because the question asks you to find P and Q, right? Given that P and Q are complex number. So recall that P is equals to A plus BI. Okay. So over here, P is A plus BI. Hence, we can write our final answer for P is negative 1 plus I. Gantikanlah. Kan? Sini negative 1. Yang ni ganti dengan 1. So, dapat yang ni. Okay. And Q. Q is the conjugate A minus BI. So kita gantilah Q. So kat sini kita akan dapat Q is equal to A. A tadi -1 minus I. Okay. So this is the final answer. Okay. P and Q, where P and Q are complex numbers. Okay. Boleh? Okay. Harapnya awak boleh faham. Okay. So Madam akan teruskan dengan contoh yang seterusnya. Okay, mari kita lihat apakah soalan yang seterusnya. Kenapa dia tak boleh detect ni? Okay, Madam tahu nak buat macam mana. Sekejap. View 100%. Okay, sekejap. Okay. Okay, tu soalan 8 So soalan 8 Madam tunjuk full solution, nanti kena cuba. Okay, ramai yang PM Madam tanya, Madam bila nak kena hantar semua ni? Untuk tutorial, please buat sendiri untuk kefahaman sendiri. Madam akan, kalau nak kutip, Madam akan tengok kepada pasir. Dan pasir tu pun, Madam akan lihat your understanding through your presentation. So, maths is for you, not for me. Awak buat tu untuk awak, bukannya untuk Madam. Okay, so tolong buat, fahamkan. Kalau tak faham boleh tanya. Dan untuk tutorial ni adalah peluang awak untuk asah skill mengira awak. So that dalam pasir nanti lancar cara nak jawab dia. Okay. So untuk topik 1, yang akan keluar dalam soalan-soalan test ataupun quiz ataupun pasir adalah bentuk soalan yang melibatkan complex number. Okay. Untuk yang real number lines tu dia tak keluar. Just untuk your understanding sahaja. Okay. So kita teruskan dengan soalan yang ke-9. Okay. Find the modulus and argument of the following complex numbers. Okay. Find the modulus and argument of the following complex numbers. Okay. Modulus tu apa kan? So kita tengok dekat sini. Okay, mungkin Madam boleh terus conteng saja. Sekejap. Okay. So apa itu modulus? Apa itu argument? So katakan awak ada complex number. Z equals to 3 plus 4i. Okay, contohnya macam dalam soalan A ni kan. Okay, terus tunjuk kat contoh lah. Okay, Z equals to 3 plus 4i. So awak boleh, you can represent the complex number. Okay, this is Cartesian form. You can represent this complex number in Argand diagram. Argand diagram. Okay, so here I can draw the Argand diagram like this. Okay, so sini real axis, sini imaginary axis. Okay, real and imaginary axis. So here, kalau tengok sini, real part kita 3 kan? Okay, 3 kan? So sinilah. Here is our real part. And here we have number 4 as our imaginary part. Okay, so kalau kita locate the coordinate, akan dapat dekat sini. Okay, so here is the complex number Z. So Madam nak sambungkan dengan origin. So Madam akan dapat ni. Oh, sorry. Okay. Sepatutnya dia besar. Macam mana nak buat Kejap. Okay, Madam tahu nak buat apa. Kita iriskan yang ni. Okay. So, sini. Allahu Akbar. Maaflah. Okay. So sini, point kita kat sini. Okay. So dia akan macam tu. So ini kita punya origin. So modulus, okay, modulus is this length. Ini modulus. Okay, kita denote dia sebagai Z bar. Simbol modulus lah. Bukan Z bar, sorry. Simbol modulus, Z bar conjugate. Okay, dan ini adalah angle di mana kita panggil dia sebagai argument of Z. Okay, argument of Z. Argument of Z. Okay. So modulus dan juga argument. So soalan ni memang minta you all cari kan. Find the modulus and argument of the complex numbers. Okay, find the modulus and argument of the complex numbers. So kita tengok dulu yang pertama, kita belajar dulu yang pertama iaitu modulus. Okay, modulus of a complex number Z. Okay, simbol dia Z bar. Okay, we can use this formula to calculate the modulus of a complex number. Okay, so di sini kalau kita punya Z, if our Z is equals to A plus BI, okay, so dekat sini formula dia akan jadi A squared plus B squared. Okay, A squared plus B squared. Macam tu. Okay, so itu untuk kira modulus. So dalam soalan ni, kita ada 3 plus 4i kan? Okay, our question is 3 plus 4i. So, for Z equals to 3 plus 4i, the modulus of the complex number Z will be square root 3 squared plus 4 squared. So, bila tekan calculator, you akan dapat 5. Okay. So, basically dia guna formula Pythagoras theorem kalau awak perasan. Okay, because we are going to find this length, the hypotenuse. Kan? So, kita ambil lah tinggi ni kuasa 2 tambah dengan bawah ni, base ni kuasa 2. Dan punca kuasa dapatlah hypotenuse. Okay, so basically dia guna Pythagoras theorem sahajalah. Okay, so that is for the modulus of complex number. So we get modulus of Z equals to 5. And the second one, we need to calculate the argument. Okay, argument ni adalah angle. Dan angle, the answer must be given in radian mode. Okay, mana calculator madam? In radian. Okay, so you must make sure you set your calculator in radian mode. Okay. So, boleh tengok. Okay, calculator mesti ditukar dalam mode radian. So, kalau calculator sama macam madam ni, just tekan on. Okay. Just tekan on. Kemudian tekan shift mode. Tekan mode. Mode kat sini, maaf. Okay. Tekan on, tekan mode. Okay. Lepas tu, maaf. Shift mode. Yes. Okay. Sekali lagi. Lama tak guna. Okay. On and then tekan shift mode. Akan keluar list begini. Ada banyak yang keluar. Jadi awak pilih number 4. Okay. Press number 4 dekat sini. Okay. Press number 4 so that you get your calculator in radian mode. Okay. So press number 4. Mana? Ikut lah. Okay. So terus awak punya calculator dalam mode radian. Dia akan keluar R kecil kat sini. Atas ni. Okay. So any angle yang you kira memang akan keluar dalam mode radian. So tak perlulah convert macam yang you belajar dekat sekolah tu lah. Sebab di peringkat matrikulasi kita tak uji dah bahagian tu. Okay. So mari kita sambung. Okay, untuk kira argument pula ya. So, Madam tulis kat bawah ni lah. So, to calculate for argument of Z, okay, kita akan tengok angle. Okay, so di sini katakan Madam lukis balik. Tadi kita nak cari angle ni. Kita tahu sini 3, sini 4 kan real. Sini imaginary part, sini real part. Okay, how to find the angle? Okay, of course kita akan guna tangent lah kan. Okay, arc tangent sebab kita ada opposite and adjacent. That's why kita kena guna tangent. Tak boleh guna sine because we boleh nak guna sine tapi kalau soalan tu just minta argument je kan. Just minta argument sahaja. So awak tak perlulah susah payah kira modulus. Faham tak? Maksudnya daripada 3 plus 4i ni awak memang dah sentiasa tahu dia punya opposite dan juga adjacent. So boleh guna tangent. Tapi kalau nak guna sin atau cos pun boleh sebab dah tahu 5 kan untuk soalan ni. Tapi Madam rasa better guna tangent. Senang sebab memang dah diberi. Sebab kadang-kadang modulus ni dalam perpuluhan. Jadi tak cantik lah nanti. Ataupun susah lah awak nak round off nanti. Okay, cuma tak salah kalau you all nak guna sin ataupun cos. Sebab dia memang konsep mencari sudut pun. Okay, tapi biasanya kita akan guna tangent. Okay, so tangent, opposite kita apa? Apa panjang ni? 4 lah kan? Sama lah kan kat sini. So it's become 4 over adjacent is 3. Macam tu. Okay, lepas tu tekan je calculator. Nak tekan, ini kita panggil apa? Ingat lagi tak? Sini, ini kita panggil arc tangent. Arc tangent kita panggil. So kena tekan calculator, kena tekan dekat shift. Okay, lepas tu baru tekan tangent. And then baru masukkan 4 over 3. Okay. Arc tangent 4 over 3. Memang tak pastilah awak boleh nampak ke tak. Tapi Mina nak tunjuk juga. Okay. Nampak tak? Bila calculator ni best sebab dia jadi pecahan dia macam tu. Okay. Arc tangent. Tekan shift dulu baru tangent. And then 4 over 3. Okay. So mari kita semak jawapannya berapa. So kita akan dapat dalam bentuk decimal. Okay, it's normal untuk dapat jawapan dalam bentuk decimal. Tak ada masalah. Okay, dan kita akan ambil 4 titik perpuluhan lah. Okay, so the answer will be 0.9273. Okay, so now we have the modulus equals to 5 and argument equals to 0.9273. And then soalan terakhir diminta express each of the following in polar form. Okay, maksudnya dia suruh tukarkan 3 plus 4i ni in polar form. Okay, apa itu polar form? Okay, tak susah pun nak tukar, tak ada masalah. Okay, so initially we have z equals to 3 plus 4i. So this is Cartesian form. Okay, we can change into polar form by writing z ataupun r, okay, equals to kejap. Let me double check. Okay. R, Z, minus Z. Okay. Modulus of Z. This is the formula untuk change. Cos theta plus I sin theta. Okay, ini polar form. Okay, ini Cartesian form. Okay, so nak tukar Cartesian form kepada polar form, first you cari dulu modulus. Lepas tu you cari dia punya argument. Okay, so tadi kita dah cari modulus kita 5. So just ganti je kat sini. Tulis balik Z equal, okay, modulus kita 5 and then cos theta, cos tulis cos. A je balik, cos. Theta kita ganti argument yang kita dapat ni. Okay, plus I sin. Salin balik. Nombor yang sama lah sebab argument yang sama. Kan? Tak adalah argument dia yang cos lain ni lain. Okay. So di sini kita boleh just tutup kurungan. So dah siap untuk polar form. Okay. So untuk kelas hari ni kita akan sambung pada waktu petang pula untuk sesi kedua kelas ganti jam berapa Jam 2:30. Jam 2:30 petang. Kita akan sambung sehingga 4 suku. So nanti madam akan bagi Google Meet link untuk kita discuss sama-sama soalan yang lain. So in the meanwhile kalau awak ada masa, bolehlah cuba soalan yang kita dah bincang ni. Macam ni 9 madam buat A je kan. Boleh sambung B, C, D. Okay, begitu juga dengan soalan-soalan yang lain. Okay. Alamak, madam tak share screen. Sorry. Okay, sekejap. Sorry, maaf. Tak perasan tak share screen. Okay. So di sini tengok balik. Mana tadi? Untuk tukar tadi kita dah tengok argument dapat 0.9273. So untuk tukar daripada Cartesian form kepada polar form, okay, mesti guna formula ini. Z equal to modulus of Z kurungan cos theta plus I sin theta. Okay. So di sini kemudian kita akan gantikan saja. Tadi kan kita dah kira modulus dapat 5. Okay. Theta dapat 0.9273. Ganti saja. Dah siap. Macam tu je. Senang je nak tukar. Okay. Maaf tadi tak share screen rupanya. Cakap sendiri. Okay. So kita akan sambung nanti. Bye.